and in this course I'm going to tell you everything I know about PostgreSQL. We're going to learn a lot about Postgres, and we're even going to start the discussion around it right now inside this video. So let's dive right in. First off, what are databases all about? Well, at a very basic level, we use databases to store information. So we take some amount of data from some source, put it inside of a database where it gets persisted in either memory or on hard disk, and then eventually we retrieve that data at some future point in time. To work with a Postgres database, we are going to connect to it using something called a client. A client can be any piece of software, so it might be some API server you put together, it might be some utility program designed to connect to a Postgres database and investigate some of the data inside of it, and even a wide variety of other different types of clients. You're going to see an example of a really interesting client here in the next couple of videos. When we connect a client to a database, we are going to write some SQL. SQL is kind of like a programming language of sorts. It tells our database some information that we want to put inside of it, that we want to retrieve, update, or delete. SQL is the number one way in which we interact with a Postgres database, so it is very important for us to understand how to understand and write SQL at a very practical level. In this diagram, there are a couple of examples of different SQL queries. So we're going to eventually write SQL to add data, read data, update it, or delete it from our database. When we start to think about SQL, it is something that is very separate and very different than Postgres itself. SQL is a communication language. It is how we interface or interact with our database. SQL is supported by many other databases as well, such as Oracle, Microsoft SQL, MySQL, and so on. Once you learn SQL for one of these databases, you're generally going to be able to use that same knowledge and apply it to these other types of databases as well. There's not always 100% clean transfer of information or knowledge going from one database to another, but in general, if you just understand SQL, you're going to have an easier time working with these other types of databases. When we start to work with Postgres, there are 4 big challenges that we start to think about, and these are the 4 challenges that we're really going to focus on inside this course. First off, how to write efficient queries to retrieve information out of our database. Remember, we write SQL in order to put information into our database, to read it, to update it, and destroy it. But out of those 4 different operations, writing SQL to retrieve information is by far the most important and generally the most complicated as well. So we're going to spend a lot of time understanding how to use SQL to just retrieve information in a very efficient fashion out of our database. The next big challenge that we're going to run into is understanding how to design the schema or the structure of our database. There are almost an infinite number of ways to structure information or data that is stored inside of your database, and it turns out that it's kind of hard to decide what approach is the best. So we're going to spend a lot of time to go over a lot of different schema designs and really understand some different concerns that goes into it. Next up, out of all these different databases that you might use when you are writing SQL, every single one of them has different sets of advanced features. Understanding when to use these advanced features is generally pretty challenging. And it might turn out that, well, you never use any advanced features out of any given database, and you just use it as a plain data storage mechanism. But Postgres itself has a lot of special features tied to it, and sometimes it makes a lot of sense to use these, and sometimes it doesn't. So we're going to investigate a lot of these different features and understand when you should be using them. And then finally, the last big challenge, managing our database in a production environment. So for example, running backups, backing up information that is stored inside of your database, scaling your database to serve more users or more traffic. There's a wide variety of different things we need to understand when we start to run a database in production. We're going to take a look at some of these different techniques and really understand what goes into them as well. Okay, so just a little overview on Postgres, a little overview on what we're going to do inside this course. So let's continue diving into the world of Postgres in the next video. Out of these 4 different challenges, we are going to focus on the first 2 items. So we're going to figure out how to write efficient queries and how to generally design the schema or structure of our database. Let's get started on these first 2 items right away. So for our first little project that we're going to work on, our first example of working with Postgres, we're going to figure out how to store a list of large cities inside of a database. The source of data that we're going to use is a page on wikipedia.org. So inside of a new browser tab, I'm going to navigate to this link right away. All right, so here is a Wikipedia page that has a list of large cities in the world. I'm going to scroll down on this page a little bit and eventually get to this table right here. Now this table has many different columns inside of it. but there are only 4 columns that I really want to care about for this first exercise. You'll notice that this table has columns of city, country, and then the last 2 over here are the population and the area in the urban area around the city. So 4 columns in total that we really care about: city, country, population, and area. Let's go through the entire process of setting up a database to store a list of cities with these 4 different pieces of information about each individual city. Now, to understand how we're going to design and set up our database to do this, we're going to go through a little design process that we're going to repeat many times inside this course. We're going to ask ourselves 3 different questions and use the answers to each of these questions to set up our database. The first thing we're going to ask ourselves is, what kind of thing are we storing? We're then going to ask ourselves what properties this thing has, and then finally, what type of data each of those properties refer to or contains. So in this case, for a list of cities, we can answer each of these questions pretty easily. So first, what kind of thing are we storing? Well, we're storing a list of cities. What properties do these cities have? Well, each one has a name, a country, a population, and an area. And then finally, the type of data for each of those individual properties, the name and the country, are probably going to be strings of characters, and the population and area are probably going to be numbers. So for this first example, answering these 3 questions ends up being pretty easy and straightforward. We're then going to take each of these 3 questions, or these 3 answers right here, and use them to actually set up our database. So here's what we are going to do with these 3 answers. So the answer to the first question right here, we said that we're going to store a list of cities. So we're going to create something inside of our database called a table, and we're going to give this table a name of cities. Let's talk about what a table is very quickly. A table is something that sits inside of our database that is going to store a collection of records that all have some kind of related meaning. In our case, we're going to make a table called cities, and then inside of that table, we're eventually going to store all the different cities that you saw on that Wikipedia page. So a table contains many records. We are only ever going to store data inside of our database inside of tables. So it's very important for us to really think about how to properly generate, name, and design the different tables inside of our database. Then from this second answer, we're going to take the different properties that each of these cities have and use them to create columns inside of our table. So in our case, we're going to make sure that our cities table has columns of name, country, population, and area. And so if we visualize what that looks like, it'd be something like this right here. So inside of a table, we have many different columns, and each column is going to store some information about a very specific property of some record. Because we want to store the name, country, population, and area for each city, we make 4 columns, one for each of those different properties. And then finally, we say that each of those different columns are going to store a very different specific kind or type of information. So name and country are going to store strings, and population and area are going to store numbers. We'll see where we are going to use that information in just a moment. Once we set up this table and the 4 columns inside of it, we can then start to add data into the table itself. So eventually, we will add in some list of cities, such as Tokyo, Delhi, Shanghai, and so on. Each of these cities will have a name, country, population, and area. Each of these individual cities that we add into this table, we refer to as rows. So right now, cities has 3 rows. 1 row is Tokyo, 1 is Delhi, 1 is Shanghai. All right, so that's a little bit of the basics of database terminology. We have tables. Tables have many columns that store information about different properties, and each record inside of a table is referred to as a row. Now that we've got a little bit of database terminology put together, and we've got an idea of how to design this cities table, let's start to actually build this thing out in the next video. We've got an initial database design put together. So we're now going to write out a little bit of SQL to interact with a Postgres database. The SQL that we're going to write out is going to create a table called cities, and it's going to have 4 columns associated with it. Now, I'm saying that we're going to work with some database, but you might say back to me, well, Stephen, we haven't even set up a database inside this course yet. Well, that is okay. Let me tell you what we're going to do. For the first little bit of this course, we are going to use an online tool called pg-sql.com. This is a tool that I put together for you specifically for this course. This is a web application that gives you a free Postgres database to run some queries on. The database that you're going to connect to is a very real Postgres database. It gets provisioned on a backend server. We're going to use this database because it's going to be very easy to very quickly run a couple of different queries and understand how to work with Postgres. We are going to install Postgres onto your machine a little bit later on inside the course. The only reason we are not doing that right away is that sometimes installing Postgres can be a little bit painful. And at the start of this course, I want to make sure that you start writing out SQL as quickly as possible. Let's go to pg-sql.com inside of a new browser tab and take a look at how this tool works. Okay, so once you go to that URL, you're going to see a page like this right here. We are going to write out some SQL on the top left-hand side inside this code editor. We'll then click on the Run button, and then we'll see the result of whatever SQL we execute on the bottom left-hand side. As we start to run queries, we'll get a history of all the different SQL that we execute here on the right-hand side. Now, just so you know what is going on behind the scenes here, we have a web application that is connecting to a Postgres database. So in this scenario, we would refer to pg-sql.com as our client. Our client is going to take some SQL, send it off to the database to be executed, and then the database will send us back a response of whatever the result of that SQL was. All right, so back over here, the first little bit of SQL that we're going to write out is going to create that cities table that we just discussed. So we want to create a table called cities. We want to have 4 different columns. For this first little bit of SQL, we're really just going to write it out rather quickly, and then we'll discuss exactly what's going on with it. So let's get typing right away. I'm going to write out create table, and then the name of our table, which in this case is cities. I'll then put in an opening and a closing parenthesis with a semicolon at the very end. Then inside of these parentheses, I'm going to write out the 4 columns that we want to create inside of this table. And after the name of each of these columns, I'm going to write out the type of data that is going to be stored inside of this column as well. So I'm going to write out name, varchar 50, and then a comma. Now, you'll recall from the last video, we said that the name column was going to contain a string. And this doesn't really look like anything related to a string at all. We'll discuss what varchar means in just a moment. After that, we'll then say that we want our table to also have a country column that is going to store values of type varchar. I'll put a 50 in there as well. And then we'll have a population column that is going to store an integer, and an area column that will also store an integer. Now, before you run this query, I would really encourage you to double check everything you have written out here. Make sure you've got a comma at the end of that line, and that line, but not the last one. Make sure you've got varchar 50. Just double check everything you've got. Once you've got everything written out inside of here correctly, we'll then click on Run on the top left-hand side. And then we can see the result of running that statement down here on the bottom left. It looks like creating the table was successful. Okay, so what did that really do? Well, once again, when we clicked on that Run button, all the SQL you just wrote was sent off to a Postgres database. The database then executed that SQL statement, and it ended up creating a table. So inside of our database, we can now imagine this is what is going on. We have one table inside of our database with the name of cities, and that table has 4 columns. Now we can start to add some information inside this table. All right, now there's a lot more going on with that query than what we just discussed, and you might be curious what this varchar is, what integer is, and so on. Let's take a quick pause here and then really break down the SQL statement in the next video. We just wrote out our first snippet of SQL to create a table inside of our database. Let's now take a deeper look at the SQL we just wrote and really understand the syntax of what is going on here. All right, so a couple of quick diagrams. This SQL statement consists of different words. Some words are what we refer to as keywords, others are identifiers. Keywords are very special words inside of SQL that tell the database that we want to do a very specific thing, or designate some particular option. Identifiers are how we tell the database what we want to somehow operate on. So in this case, create table is an example of a keyword, and cities is an example of an identifier. Keywords are always going to be capitalized, and identifiers will always be all lowercase. Now, out of this entire SQL statement, it went over a collection of different lines. Each line has a very distinct purpose to create the cities table. The very first line, create table cities, as you'd guess, creates the table itself. Then, inside that set of parentheses, we listed out all the different columns that this table should contain. In total, we said that we wanted 4 different columns, so name, country, population, and area. Then, right after each of these different column names, we listed out the type of data that would be stored inside of that column. So we said that name and country were going to contain data of type varchar 50, and population and area would contain data of type integer. So what exactly is a varchar 50 or an integer? Well, these are 2 examples of column data types. Varchar 50 is short for variable character. You can think of this essentially as a string. It is a string of characters. The 50 in there means that we never expect to try to store a string longer than 50 characters. If we ever try to insert a city with a name or a country longer than 50 characters, then Postgres is going to give us an error. So the number on here is just restricting the length of string that we can put into this field. Population and area designated a type of integer. Integers in Postgres are numbers without decimals. They can range from about -2 billion to about +2 billion. If we ever try to insert a value into population or area larger or smaller than negative to +2 billion, then we're going to end up getting an error. In our case, we are going to store a list of cities. So we kind of have to ask ourselves whether or not we ever expect to have a city with a population greater than 2 billion or an area greater than 2 billion. Well, right now, Tokyo is the largest city at about 38 million. So I don't really expect us to have a single city with more than 2 billion people inside of it anytime soon. I'm sure you can make the case and say that maybe in 100 years or 1,000 years, there's going to be some really large cities out there, but for the purposes of this example, I don't think we're ever going to have a population greater than 2 billion inside of one city. Okay, so that is the meaning of that little piece of SQL right there. Now we're going to take a look at many other examples over time of SQL. We're going to see many other data types as well, besides just varchar and integer, but they are at least a good place to get started. Now that we've got our table created and we've assigned some type of data to each of these different columns, we now need to figure out how we can actually insert data inside of here as well. So let's take a quick pause and then understand how to insert data into a table in just a moment. Let's now figure out how we can add data into a table. So we've got our cities table. We want to add in some information about the cities Tokyo, Delhi, Shanghai, and Sao Paulo. I've got the countries listed here, along with the populations and the areas as well. We want to take all these values and get them into the cities table. To do so, we're going to once again write out some SQL. So back over here, I'm going to delete the create table statement, and we will replace it with insert into. So these are the keywords that we use to insert some information into a table. We'll write out insert into, and then the name of the table, which in this case is cities. And then inside of a set of parentheses, we're going to add out a list of all the different columns or values for columns that we are going to provide. So we are going to provide a name, a country, a population, and an area. Then on the next line down, I'm going to put down another keyword, values. After the values keyword, we're then going to list out all the values that we want to put into this table inside of a set of parentheses. So the very first city we're going to add in here is Tokyo. So I'm going to put in a set of parentheses. I'm going to put in Tokyo inside of single quotes. Notice I'm using single quotes here, not double quotes. Then Japan. Then our population of 38,505,000. And then the square kilometers. So 8,223. I'll then put a semicolon at the end of the line. Now you might have noticed that on the create table statement, we used a semicolon at the very end as well. Inside of the SQL standard, technically we do have to put in that semicolon, but in this interface, it is not actually required. So if you do not put on that semicolon at the very end of the SQL statement, that is technically okay, but I highly recommend you add it in, especially once you start to write in multiple statements inside of one query. All right, so let's now try to run this. And as soon as we do, we'll see insert successful, one row inserted into that table. Okay, so that's pretty much it. Now, what we've got here definitely works, but there's a little bit of trivia around the insert into statement that I just want you to be aware of very quickly. So first off, we listed out all the columns inside the cities table right here in a very distinct order. So name, country, population, area. If we wanted to, for some crazy reason, we could decide arbitrarily to kind of jumble the order of columns. The only requirement is that when we list out all the values we want to insert, they match up in the same order as the order in which we listed out all of our columns. So it has to map up in this way. Let's imagine what would happen if we swapped the word country with population right here. If we did this, that would mean that we want to insert the string Japan under the column population, and for country, we would want to insert the value 38 million. And that's definitely not what we want. So we just need to make sure that whenever we list out these different column names, we always provide the values to go in the same order as well. Okay, so now next little bit of trivia here. We want to insert 3 other cities, and it would be a little bit tedious to have to write out 3 separate statements 3 times over and run these 3 things just to get 3 rows into our table. So if we want to, we can actually insert multiple rows in a single statement in one go if we want. Let me show you how we do that. I'm going to delete everything after values, and then on the next line down, I'm going to open up another set of parentheses, and I'm going to list out all the values for Delhi, India. So I'll put in Delhi, India, which has a population of 28,125,000, and 2240 is the area. And then after I list out all the values for Delhi, India, I'll make sure I close off that set of parentheses, put a comma, and then on the next line down, I'll put in another set of values. So this additional set of values right here will be inserted as an additional row, all inside of the same query. Now we can put in Shanghai, China, the population of 22,125,000,415. I'll put another comma right there, and then finally, Sao Paulo, in Brazil, 209,350,000, and an area of 3043. That's how we can insert multiple rows at a single time. Now I'll run that query, and now we can see in the output down here that we successfully inserted 3 separate rows. Okay, so that's how we insert 1 row at a time or multiple rows. Now the last thing we really have to do is figure out how to retrieve this information out of the cities table. Let's take a look at that in just a moment. We've now got some information stored inside the cities table. So now we need to figure out how to somehow fetch it or retrieve it. To do so, I'm going to delete this statement, and I will replace it with a very simple way of pulling information out of a table. We are going to write select star from cities. I'm then going to run this, and we can see the 4 different cities we've added up to at this point in time. Cool. You can see that pulling information out of a table in a very basic way is somewhat straightforward. You might be curious, what does the star right there really mean though? Well, the star inside this query means that we want to get all of the different columns inside of that cities table. It's kind of a shortcut. It means give us all the different columns. If we want to, we can designate just specific columns we want to retrieve out of our table. So for example, if we only wanted the name and country columns, we could write out select name, comma, country from cities. Let's try that out really quickly. I will replace the star with name, comma, country. If I run that, I get only those 2 columns. We can also do, say, the name and the population. So we get name and population, and of course there's no limit to how many we put on here. So I can also specify name, population, area. We can change the order in which these are listed. So I could put in first the area, then the name, and then the population. Yep, that works as well. We can even list one column multiple times. So for example, I could put in name, comma, name, run that, and I get the name column 3 times in a row. Now this might seem entirely pointless right here, but you'll see very quickly that it's actually quite useful sometimes to be able to print out values from a single column multiple times. You'll see an example of that rather quickly. All right, so that's the basics of pulling information out of a table. We just remember select, list out the columns, or a star if we want to get all of them, then from, and the name of the table that we want to get some information from. We've now learned how to pull data out of a table, and at this point, it looks like we just used SQL to pull raw information out of our database. In other words, we stored this exact set of information, these exact columns right here, and it appears that we can just pull exactly those columns out. But it turns out that when we are making use of SQL, we can actually somehow transform or process data before we pull it out of the database. Let me show you what I mean. So if we think about our cities table right now, you'll recall that we have population and area in here as columns. There might be a really useful metric that we could try to calculate for all these different cities. Maybe we could try to find the population density of each city, which would be defined as each city's population divided by its area. That would give us the population density, the number of people per square kilometer in this city. So we would want to calculate that value for each individual row. To do so, we would eventually end up with something that looks like this right here. We would take Tokyo's 38 million and divide it by 8223. We would take Delhi's 28 million and divide it by 2240, and so on. This is a calculation that we would want to repeat for every single row inside of our table. Let's figure out how to write a little bit of SQL that will automatically do this calculation for us for each individual row. Okay, so back over here, I'm going to delete the star that I had previously, and then I'll print out each individual city's name, and then after that, I'm going to calculate each city's population divided by its area. So in this case, we are doing a calculation right here. You can imagine that we are kind of making an imaginary column inside the database, kind of like a temporary calculated column. If we now run this query, we'll see that we get the name of each city and then the population density right next to it. So this is the number of people per square kilometer in that city. We are not limited to just using division operators. We can also use many other math operators, such as addition, subtraction, multiplication. We can find the exponent between two columns, square root, absolute value, remainder, and so on. There are even more math operators than what you see right here, but these are some of the ones you're going to use most frequently. And even out of these, you'll most frequently just use the ones on the left-hand side. So for example, if we wanted to find, for some crazy reason, it doesn't really make a lot of sense, but maybe the population plus the area. We could put in population plus area like so. All right, looks like we get a large number there that looks more or less accurate. We could multiply the two. And if we do so, we end up getting an error here because remember, an integer value inside of Postgres can only go up to about 2.14 billion. In this case, if we try to multiply the population by the area, we get an integer value that is too large. And that's why we see an error here of integer out of range. But regardless, we can imagine that yes, we can multiply two columns by each other. So I'm going to take this back to population divided by area and run it again. The last thing I want to mention here is that you'll notice that the result that we get right here has a name of question mark column question mark. The reason for that is that Postgres understands that we are doing a calculation right here, but it doesn't really know what to call the result. It's not going to call it for us automatically something like population divided by area, so it just gives us kind of this temporary name right here of question mark column question mark. That's not a very helpful column name because it doesn't really tell you and I what the values in here are really all about. So what we can do to make this a little bit more clear, just for you and I, is rename this calculated column. To rename a column, I'm going to put a new line right there, and then right after the calculation of population divided by area, I will write in as, and then population underscore density. So that will calculate a new value, and then name this new temporary calculated column as population underscore density. Now, if I run that, I get a column name that makes a lot more sense. And it's a lot more clear about what all these different values are really trying to tell us. We do not have to call this population density. We could call this column anything we want. So it could be just density by itself. Now we get a column named density. Okay, so that's a little bit on math operators and how we rename a calculated column as well. Let's take a look at an exercise for calculated columns just to make sure that this whole idea is crystal clear. So in the next lecture, you're going to see a quick exercise. In this exercise, we're going to be working with a table called phones. The phones table has a name column, manufacturer, price, and units sold. Your goal is to write a query that's going to select the name of every phone and also the total revenue for each phone, which is calculated as price times units sold. You'll then also want to rename that calculated column to be called revenue as well. Okay, so if we look at this in diagram format, this is the data that we are working with. We've got name, manufacturer, price, and units sold. And what we really want to do here is generate a new column called revenue, and that's going to be the price of every row times the units sold of every row. So go ahead and give this query a shot. As usual, if you get stuck at any point, don't sweat it. We'll go over a quick solution in just a moment. Just as we can use operators to manipulate numbers, there are also a set of operators we can use to manipulate strings. And in addition to these operators, there's something else called functions we can use as well. So in this video, we're going to take a look at a couple of different string operators and string functions. These are all about somehow working with strings in one way or another. On the screen right now, I've got a partial list of one operator. So this is an operator we can use to join two strings, and several different functions we can use as well. We have not looked at functions in SQL just yet, but these functions work very similar to how functions work in many other programming languages. Let's take a look at an example of how we would join two strings using either this pipe operator or the concat function. Okay, so back over at pg-sql.com, I'm going to try to select the name and country of every city, and I'm going to join them or concatenate them together by using that pipe operator. So we would write out select name and then pipe. Now those are not L's, they are not I's. They are the character that is to the right, just top of the return key on your keyboard. So I'll put in that symbol twice, and then country, from, cities, like so. I'm going to run that, and then we'll see that we get back a result of Tokyo, Japan, Delhi, India, and so on. Now, we probably don't want to just take the name and country and just join them directly together, because the result is kind of hard to read. So we might want to put an extra little comma in there and maybe a space as well. So something that says Tokyo, Japan, just to make this a little bit easier to read. So to do so, we can concat with string constants as well. Right after the first double pipe, I'm going to put in a set of single quotes. Then inside there, I'll put in a comma and then a space. On the other side of the single quote, I'm going to put in another double pipe. So this can be interpreted as give me the name, then give me a comma and a space, and then the country. Let's try running this. All right, that's a little bit more legible. Now, just as we saw with some of those different other operators for mathematical operations, SQL is renaming, or Postgres is renaming this column to column ? So we might want to put in another as keyword here to manually rename this generated column so it's more clear what this column is all about. So I might put in an as location. Now, if I run this again, I get a much better little column name there that's a little bit more clear about what is going on with this data. All right, so that is an example of an operator. We can use a function called concat to also join two strings. So this pipe operator and the concat function do the exact same thing. It is simply the syntax we are using that makes the difference. Let's try doing the exact same operation using concat. I'm going to delete name all the way to the end of country. I'll then replace it with all capitals concat. I'm going to call it as though it were a function, just like we would call functions in many different programming languages. And then inside of here, I'm going to add in a couple of different arguments. So the arguments I put into this function are going to be the different strings that I want to join together. So I want to try to take the name of every row, and I want to join it with the country of every row. So I'll put in name, comma, country. I'll then run that, and we get the same operation or the same result that we had before. So it definitely works equivalent to that pipe operator. Again, the syntax is just a little bit different. Let's try adding in that extra little comma and space once again to just get a little bit more separation between the city and the country. So right after name, I've got the comma right there. I'll then put in an empty string with single quotes. I'll put a comma inside there and a space right after. And then outside of the single quote, I'll put another comma. So the syntax, again, kind of hard to read, but we're essentially saying take the name, take a comma and a space, and the country, and join those three strings together. So I'm going to run this again, and I get the same result I had before. All right. We could also make use of other functions for manipulating strings, such as lower or upper. That will give us the lowercase or the uppercase value of some column. Let's try turning the name and country right here into uppercase and then joining them together. We can stack together as many functions as we want. So rather than deleting anything here, Let's try to wrap name right here with a uppercase function call. So right in front of name, I'm going to put in upper, and then close off the parenthesis on the other side. And I'll do the same thing over here for country as well. You'll notice now that my query is rather long. I'm going to click the Format button at the very top to automatically format this query just to make it a little bit easier to read. Now if we run this, we get everything in all capitals. We could, of course, instead of putting upper in front of name and country, we could try to get the uppercase version of what comes out of the concat function. So for example, if I undo the changes that we just made, so I'm going to take out the upper right there, I'm going to take out the country upper right there as well, and then I will wrap the entire concat statement with an upper function call. I'll make sure I get an opening parenthesis right there, and then a closing parenthesis on the very other side. I'll then run that, and I get the exact same result. Okay, lower is going to work very similar. It's going to give you the lowercase version of a string. And the length function is going to give you, as the note says right there, it's going to tell you the number of characters in a string. Length might be one of the more useful functions that you're going to make use of if you ever want to find strings of a particular length. We'll see some examples of that later on. All right, so we've taken a look at another operator. In this case, it is a string operator. And we've also introduced the idea of functions as well. Let's continue on in just a moment.